Well, it's Friday afternoon and one of our viewers sold me this for 20 quid. So he was offered it, and I said I would buy it off him if he so wished, which he did because he'd already got one. And we haven't got a complete one of these, so hopefully the box isn't empty. It'd have been really sensible if I'd have got a knife on here, but I've got some little precision cutters. So you never know, we might be able to get into it with the precision cutters. This video is going to be hours, isn't it? Was it Rolf Harris who used to say, "Can you tell what it is yet?" It's like Christmas at Tango Towers. When the music stops, you can take another wrapping off the parcel. I don't ever think I've ever seen the box for one of these, however tatty and incomplete the box is. So, we've got an Alba CBH2. As long as the aerial's intact, we're alright, aren't we? Yep, I can tickle the camera up there with the aerial. Excellent. I always thought this was the smartest looking one, but if I'm right, is this the one that didn't even come with a carrying case? I'm sure the Harvard and the Harrier did. I think they both came with a carrying case, but I never remember seeing a carrying case for one of these. They were a soft case, they weren't as robust as the realistic. Look, it's got even the label missing, you know, stolen from Edinburgh Council or whatever. So you can see there's no pressure on that foam rubber. So that's good, because I don't think it's had much battery in it. They're dreadful, aren't they, these contacts? We're going to have to do a on the air test with this, and we're going to have to make it work with batteries. And I think the best thing to do, if you want to try and use one of these, and they're a bit of a fragile set, the Harvard, the Harrier, and it's a bit fragile, and the Moonraker Master. But if you want to use one, I would be tempted to get some of that double-sided sticky foam and stick it under the negative contact. Cut it carefully and stick it under there, so that these don't push inwards and sprain, because that's what happens. Well, we'll see whether it powers up. And I've got this time a 2.5mm connector, because we did a little video on what does this socket actually do, because some say external power, some say charger, and some say diddly squat. So it's positive inner, it's 2.5mm mono plug, and be aware that as you plug it in, it shorts out your power supply. So it's sensible to switch the power supply on later, like now. And also remember, these are a 12 volt radio, they're not a 13.8 volt radio. That's why, as it says there, 2 dummy batteries if you're using alkalines. So you put 8 alkalines, 2 dummies, 8 times 1.5 equals 12 volts. And if you use rechargeables, and RRS ones are too thick, so you can't even fit them in, it's 10 because they're 1.2 volts. That's what that's about. So theoretically it'll power up. And it does. And if we put this into our test set, I can hear the signal generator, which is even better. So if I switch picture in picture on and we press transmit, the radio should do 2.5 watts. I think it's 2.5. I've got the manual here to check. It's doing exactly 2 watts. So that's probably what it's supposed to be, and it's me who's lying. If I dig out the service manual, we'll just make sure, do you know, I see so many really broken ones of these, or messed about with ones of these. It's a pleasure to have one that actually works as presented. And just for, we can't tell you what the Synad is because it hasn't got an extension speaker socket. So we have to actually take the board out and go onto the speaker, which is a pain. But we will do that for the video. Okay, so I've dug out the service manual and it says 2 watts, so it's spot on. If we can read the photocopy of the scan of the photocopy, it says 1.8 is the absolute limit. So there we are. Good. So we'll take it apart and go through the tuning. Switch off the power supply. So it's a matter of kind of gripping. I've taken the screw out. You kind of have to grip this and then pull. So any of you have been to a nail bar and you've got long nails, it isn't going to happen. Then the top pops off. It does, I promise you. There's a piece of adhesive tape just there, a bit of glue. Then you can withdraw the aerial. And there we are, we're into it. And what we're going to need to do, we can do the transmitter with it in the case like this, but we can't do the receiver because we need to get to the back of the speaker to do Synad. So you got high-low power switch. So high is in the low position. High is in the down position and low power is in the up position. And that of course is going to save batteries and not, you know, when you're wanting a closer range, that will save batteries dramatically. So what do these draw? 650 milliamps or something like that. So we need to plug the aerial back in. So it's 3.5mm jack. The adapters are available, and I've got, should have got one in here, except I haven't. But like we have the RCA and Phono and Motorola adapter there, they do a 3.5mm one, quite easily available. But we made a lead up. So we'll go through the transmitter. This isn't going to take much doing because it's working. They do the face lock loop, we don't need to do that. So adjust T2, 3, 4 and 5 for maximum output at 27 megs. 2, 3, 4, 5. So, looking at it this way, it's all mirror image, isn't it, this? 2, 3, 4, 5, 2, 3, 4, 5. Except we're going to start at 5. So switch the power supply back on. Press transmit. You know what? That's now over. That's spot on as it was. So we've now got 2.5 watts. We need to drop that. Do they tell you what to do to drop it? Let's see what current consumption we're taking. 580. Let's see what it's supposed to be. It's supposed to be 650, so it's actually being quite efficient. Yeah, 750 is the limit. You want you to check it with a spectrum analyzer, so we will do. Whilst that's coming on, we may as well do deviation. What I'm going to do, I'm going to use the call tone because it has a call tone. So that if I put this on, there we go. Press transmit. It's actually peaking at 2.5, which is actually where we want it. Wow! It's a bit too loud. So it's VR1. Of course, I can't remember which one that is, can I? VR1 is going to be that one. So having that call tone makes it easy. So we'll set that to 2. Wallow. And there we are, we've got our peak at 2.5. So I didn't have to bother with the external oscillator. I've just been attacked by a mad Moonraker master. It looks like it was coming to join to see what the other handheld was on the bench, seeing it as competition. So we've set the deviation VR1. Meanwhile, the signal generator, the spectrum analyzers come on. Let's put in 27,79125 megs, and we'll just loosely couple that. We'll just clip that around the insulation of the aerial wire. We've got, for those of you who don't know, we've got a big attenuator and all that on the spectrum analyzer. I could connect direct, but I try not to. So what are we going to see? Let's clip that to somewhere. We're not going to see anything. Tell you what, we'll go on low power and we'll clip directly to the antenna. And there we have it. Oh, I didn't press the button. So there we have our fundamental frequency, and I'll just put in double that frequency, 55 megs. And I can just see we've got something on the edge of the screen. It's actually 82.7. So if that's all the rubbish coming out of it, that'll do nicely. So what we're going to do, I'm going to turn down, I'll go back to 27 megs. So I think we'll do exactly what they did and turn down the drive circuit so that it's 2 watts. So we'll come off that and go back to the, then we'll check it's still clean. So on this one we'll go back to the power meter, switch back to 4 watts, sorry 2 watts, detune it, set it to 2.05, how about that? You know what, while we're at it, we'll put the thing on frequency. So with the trimmer capacitor here, it's dropped 27,79125. It's within spec, but I'd like it as close as possible, of course. Bit too high for me. We'll have it at there, then it's got room to drop, which you do with age. So we're doing 2.1 watts now. The radio's drawing 550 milliamps. We'll put it back to low power and we'll look at the spurious on here. There's the clean signal on 27. Oh, I'm not showing you. There's the clean signal on 27. And once again, we'll put 55 in. Frequency 55 megs. Key up. And we've got nothing. We had that one at 80 something before. It's just there, it's actually dropped. So actually turning the power down has removed the harmonics. But really it's very clean, especially for a 1981 set when the spec was a bit lower than it is these days. So I'm satisfied that's transmitting fine. We're done with the spectrum analyzer. And I think this is, turning down the driver is better than messing about with the output because of the cleanliness of the signal. We could check that the aerial, the internal aerial, is set as well as can be. I'm going to disconnect the instruments, pull up the telescopic aerial. I had a really strange comment on the last handheld I did. Something about it must be an open space and not touching anything and all kinds of things. Well, I don't know what they think I'm doing, but you know, there's a gap between this bench and the next, and the telescopic aerial is over the bench in free space. So there you go. So what we now want is to weigh that down, because it's going to disappear off the bench. What I need is a field strength meter. So I could do with putting a bit of a crocodile clip lead on this to work as a short aerial. I never seem to have one on this bench. Not sure what that goes to. But it'll do. So with the aerial in free spray, and like, what was his name who played, was it Sean Connery? Shaken, not stirred. So we can see we've got, on the meter, it's picking up the field. So we want to adjust. I'll just make sure this isn't too tight before we adjust it with the ceramic tool. For maximum, where it is correct. Look, if I turn it, can you see it going down? So where it is actually the peak. So we've done that. And I can assure everybody the aerial is in free space. So that's that done. So that's the loading coil for the aerial. So we'll pop the aerial back down. Just like that. And we'll put this back on the top shelf. It says made in Japan on the back. What about that? I wonder if Zetagi do a field strength meter. Oh, that's a really good point, isn't it? We got a dummy load. Yeah, we've got a dummy load. We've got our Zetagi meter here. So we know it's doing 2.05 watts. Now, last time we did this on low power, the Zetagi meter actually read short. So, whereas it usually tells you you're doing far more power than you really are. So let's see what it's doing. We should have 2 watts. Yeah, we're doing 300 milliwatts according to the Zetagi meter. It doesn't like low power, does it? I don't think it needs my explanation as to what all this inaccurate meter game is all about. What it means, because we all know, because we're not stupid, that Zetagi make illegal linear amplifiers. They want their illegal linear amplifiers to look like they work better than they do. Their 100 watts equals 45 watts. Right. So I don't know if we can adjust the power meter on these. At least I think does it adjust? Let's have a look. Yeah, second harmonic should be 80 dB lower than the fundamental, but there wasn't one at all, so that's excellent. Okay, So now we're going to have to take the radio out of the printed circuit board out. If this was a repair, we wouldn't need to, because it's working beyond what specification is. But just for the video, we're going to take the board out. Having said that, every one of these I've seen recently, I've had to take the board out because of malfunctions. This pillar, there's a plastic pillar this screw goes into, is nearly always broken, and I end up having to glue it back, and then having to wait for the glue to go off before I can finish the setup, which is a pain. But this one doesn't appear to have been dropped. Didn't say I could get that out. And then you've got a screw there. So the meter holder, the screw here. I'm going to switch the power off again in case I short something out withdrawing the printed circuit board. The output transistors are hard to get and expensive. MPSU31, we have them in stock, but I had to import them from the States, so it's not just the cost of the device, it's the cost of post and import duty. What we're trying to do is to get to the... it's got all the screws in this set. I've not seen that one fitted for years. Now these are a double-sided board, but they don't tend to play up, which is great. So what we're trying to do is to get to that speaker. And I think the easiest thing to do is to solder a bit of wire onto the positive, so we've got a bit of wire coming out of the radio, rather than trying to get crocodile clips onto the very low profile speaker, which you can't get. We can get a not quite as big one from RS, and that's what we've recently had to do. It's usually going to be water ingress that's going to have killed off the speaker. If people leave these things out in the rain. We've got a scrap remains of an amp strap, we can pinch a bit of wire off. We have reels of wire, of course we do, out in every colour there is, but they're in the other workshop. So that's that connected. Now if they'd put an earphone socket on like Realistic did, we wouldn't have this problem. So back to plugging in the aerial, switching the power back on, they're quite a simple receiver, and they're not a very selective receiver, so don't expect marvels. The same circuits used on the Eurosonic Euro 1 and 2 mobiles, but as a mobile and with 4 watts output, and also the CBM1, the Alba CBM1, which is a mobile with slider controls. Every television set had slider controls in the 80s. That was the thing. They're not very good for noise, but nevertheless the Alba CBM1 had them. And I noticed one of those on eBay at the moment. It says super rare. Well, you know, it isn't super rare because I've got at least 2 of them here. So let's look at what the manual says. So we know it's none of those. I think there's just a couple to do there, to be honest. We're not going to mess with the VCO. I don't think we're going to get much more out of it. I don't even think there's a detector coil to do on these. Alignment. Now the speaker's 16 ohms they want you to put on your test instrument, and we're at 8, so we're never going to be able to read things like the power output on this bench. So it says it should do 400 milliwatts. We're not going to be testing that because we're at the wrong impedance on the test gear. How to use a sweep generator to look for a symmetrical S-curve of 455 kilohertz. How to do the phase lock loop, which we're not going to do. So receive. So it says bypass the loading coil. We've bypassed the loading coil because we're plugged into the socket. Otherwise you'd have to take that out and solder a little lead on there if you didn't use the socket. Why doesn't it say plug it into the socket provided? Well, it doesn't. So adjusting T7 and 8 for maximum audio output, so they, yeah, 7 and 8. So it's those two. So we'll connect our synod meter to this. All I need to do is hold the wire on, because I'm not going to be a jiffy. And we'll switch to that right now. So we'll drop the signal a bit till we get about there. Hello? Where's the signal gone? Let's have a look at some of these IF ones. Let's see what it's doing cyanide wise. Don't expect any miracles. Just go through these again. .12 decibel cyanide is 1.2 microvolts, so not brilliant. About par for the course. Yeah, right. So limit spec is 1.2 microvolts for 10 decibel cyanide. I've got it to 12 decibel cyanide. So let's see what we've got for 10 decibel cyanide. So there's 10 decibel cyanide, 1.1. So it's well within the limit spec there. Their pie in the sky one is 0.5 microvolts. So let's move on to adjusting the S meter. I think you can do that. VR5 for S meter. VR5 for S meter. That's the one at the bottom. So with the signal, I'll tell you what, we'll now take that away and put the radio back together. I'll pause the video while I do that. Okay, so we're now at the stage, we'll put S9 on the signal generator, so it's 100 microvolts for S9 in the UK for CB. So let's see what that reads on that little tiny meter. I'll just put about 5 pairs of glasses on. It's reading 7, so we'll just pop that up a fraction. So that now reads S9. What does it read on transmit? I don't know whether it's RF power. Let's see. Drop it to... It makes no difference whether you're on high or low power. It's probably a battery meter, like they usually are. But there aren't many handhelds with a signal meter on receive. None of the realistics have got a signal meter on receive. Even the 1005, that's a battery meter on receive and a relative power output on transmit. So that just leaves squelch. So this is where these sets are let down, but you have to bear in mind it's a handheld and you're not trying to squelch out off a base station aerial. Though we'll be doing an on-the-air test with the base station aerial, and we will also be doing a field test with Mr. Chippy and a body cam. Right, turn the squelch to full. Let's see when it comes in. 1 microvolt, 3 microvolts, 10 microvolts. Any improvement on that? No, that's already at full. Oh, we've got a bit more out of it. Oh no, that's no good. It never ever comes in. about 10 microvolts. We'll test it now at the sensitive end. Turn the signal generator to standby, park it at 0.3 of a microvolt, advance the squelch control to threshold, switch the signal generator back on, it's coming in at 0.74 of a microvolt, and it's leaving us at 0.2. So I mean the radio is receiving down to 0.25 microvolt, but not with the quality of signal to give us the 12 decibel cyanide. So it's not that it's deaf, it's just that it's noisy with it. So there we are, we'll put it back together. I'm just going to check that we're being presented with power across. Normally we power them from crocodile clips to the battery lugs, but we're just going to check that we've got power up there. Here we have, which means that when we put batteries in it will actually work, subject to the dodgy battery contacts. Okay, so now I'll just kind of put it together, so moving that slightly to get that in and making sure we're not trapping any wires. That looks about right. Find we've lost the screw. Where's that gone? I think it must be that one. Oh great, the one I've just dropped on the floor. Pause the video. So we'll worry about the screw for the back later. So plugged into the aerial. 19 Roger. Okay, usual nothing. So we'll do an on-the-air test and we'll do a field test on that. So there you have it, the Alba CBH2 from 1981. I recall there was $69.99, and it's nice to have one in the books, and thank you to the viewer who sold me that.